Alright, so I did end that video abruptly because there is a 15-minute recording limit. But this software is pretty amazing, and I do highly recommend it if you are going to use this to record videos on your computer. Alright, so continuing from our part 1 video, we were talking about why this equation makes sense. Moving on to the variables on the bottom. It makes sense that if there's a greater gap between the two surfaces, or a greater velocity, or a greater thickness, and heat capacity, that there would be less performance. What this would do is this would make the denominator less, which would in turn make this quantity here. If the denominator is greater, right, all of these constants being high, it would make this quantity lower, and so it would thus lower the value of the denominator. And if the denominator gets is less, then this entire quantity here will be greater. And with a greater entire quantity, our temperature difference will be greater, indicating that the heat didn't transfer as much from the hotter fluid to the colder fluid. And this indicates that there is not a very good performance. So this is why the equation makes sense. And I do this for a lot of the equations I derive, just to check for reasonableness, to check if they're reasonable, and that they make sense. That was redundant. Alright. So I will be covering the next problem, problem A2, in the next video. And so let me just quickly summarize what we did. We identified the unknowns, and we also identified the given constants. And we labeled the unknowns with variables, and we put the given constants in terms of those variables. And we asked ourselves what we were finding, how we could write the quantity in terms of the unknown, and how we can find those unknown. And in this case, we simplified 2 of our variables, so that we only needed to use 3 of our variables, the entry temperatures and the temperature difference. And we solved it, and we realized that we didn't know what the temperature difference is, so we simply used the power equation they gave us, and the Q equals mcat equation from thermodynamics. And since we knew that there was 2 unknowns, P, and the whole reason why we came up with this equation is because from the power equation they give us, we realized that there's 2 unknowns, so we need another equation. And so from that second equation, we were able to solve for the temperature difference, and we were able to plug the temperature difference back into our initial equation. So the problem itself is not that hard, but the hard part is coming up with the right process for solving for the variable T final. The next problem is going to be much easier than this one, but I do have a feeling that this question should have been, even though I would say that the questions are not necessarily ranked in order, I would make this an A3 problem. It really wasn't too difficult. Alright, I'll see you in my next video. Peace.